Hi everyone, welcome to Violin Coding. I'm Eric. Today I'm going to show you how to set up a production-ready MLFlow stack on your local machine. MLFlow is a leading open source platform for managing machine learning lifecycle. It has four major components for this job: MLFlow tracking for recording and querying experiments. MLFlow project helps us define a package format for our ML project so it can be reproduced in any platform. MLFlow models help us deploy our models in various environments, and MLFlow model registry creates a central registry for our models. Getting MLFlow running on your computer is really easy. You first need to install it with pip install MLFlow. It probably takes a minute to install everything. After the installation is finished, you can start the tracking server with MLFlow server. This will spin up the MLFlow tracking server listening on port 5000. If you paste this link into your browser, you can see the MLFlow tracking UI. If you check your current directory, you can see that under the hood, MLFlow has created an MLRun directory with two subdirectories. By default, when you install MLFlow via pip install, it will use your local file system for storing both the metadata and artifacts of your experiments. While it is probably fine for your development purpose, it is certainly not scalable for production. One of the best practices I've learned when working on machine learning projects is to have my development environment as close to the production one as possible to mitigate any problems caused by the differences between these two environments. So entering our production-ready MLFlow setup, at the heart of our setup is still the MLFlow tracking server, but instead of the local file system, we will use PostgreSQL, a relational database, as our backend to store experiments metadata such as metrics and parameters. MinIO, an object storage that is compatible with AWS S3 to store experiment artifacts such as model checkpoint, plots, and figures. Our MLFlow stack is containerized with Docker. This means that the entire stack can be set up or torn down with a single Docker compose command. You can also easily share this setup with people in your team so everyone has the same setup for machine learning tracking. You can also easily replicate this setup on production with cloud services. For example, MinIO can be swapped to AWS S3 or GCP cloud storage with some change in the configs. Without any further ado, let's get to setting up our MLFlow stack. Just to be a bit more organized in our project, let's create a Docker folder and add a Docker compose YAML file. The first step is to set up PostgreSQL server and create an MLFlow database that we can use in the MLFlow tracking server later. So we're going to define a Postgres service which uses the latest Postgres Docker image from Docker Hub and set the container name to something like Postgre. Then we expose PostgreSQL default port 5432 inside the container to port 5432 in our host machine so we can access the database from our machine for testing. Next, we need to set several environment variables for PostgreSQL, particularly the user, the password, and the database. As a good practice, we don't include these credentials directly in our YAML file, but read them from an env file that can be ignored in our Git repository. We'll create this env file in just a second. We also need to define the volume section. This defines the Postgre data that is mounted to this directory where PostgreSQL stores its data. This way, our data is persisted and won't be lost if we destroy our container. Next, we put an init script to the Docker entry point of the container, and we will create the MLFlow database in this script. Let's not forget to define our volume. Okay, let's create an env file within the Docker directory and add those credentials to PostgreSQL. Then let's create the init script inside PostgreSQL directory. This script just contains a single SQL statement to create the MLFlow database. Alright, let's build our Docker image and start the container with the docker compose app command. I'm using Docker Desktop. You can see that a container has been created and is running. I'm also going to try to connect to this database. And we can see that there is an empty MLFlow database created. So the first step in our setup has been successful. Next, I'm going to set up MinIO. It's an object storage system that is compatible with AWS S3. We need to define the MinIO service, which uses the MinIO Docker image hosted on key.io, and set the container name to something like MinIO. For port mapping, we have to define two mappings, port 9000 for the MinIO server, and port 9001 for the web console UI. We also need to set three environment variables, the root user and root password, which are similar to the AWS asset key and secret keys used to set up the connection to your S3 bucket. Then we set MinIO storage use HTTPS equal to false. This will allow MinIO client to connect to the MinIO server without TSL verification. Then we define the command for this container which run the MinIO server with the root data directory set to data. The console UI run on port 9001. And we also define a persistent volume for MinIO. And we also need to add this volume to the volume section down here. Let's not forget to add our environment variables to our .env file and save it. Alright, let's run docker compose app command again. Docker will pull the MinIO image and build the container. We can see that our container is created and running. If we go to localhost 9001, we can see the login page of MinIO. We can log in with the MinIO admin as username and password as we set in our .env file earlier and see the interface of our MinIO. So yeah, the setup is successful. Before setting up our MLFlow server, we need to create a bucket for it to store experiments artifacts. We can of course do so manually in the interface. However, I want to automate this process, so as I said earlier, our MLFlow stack can easily be set up or torn down with a single docker compose command. For this, I'll define a MinIO setup service that uses the MC, the MinIO client image, and set it to be dependent on the MinIO service, so it only starts once the MinIO service has started. And I mount a create bucket bash script from my code repository to the container, make it executable, and execute the script. I also define two variables, MinIO root user and root passwords, so the bash scripts can access those values. Let's go ahead and create our MinIO directory and the create buckets.sh script inside. The content of this script is very simple. First, we set an alias named MinIO server to the URL of our MinIO server and the root username and password. Then we run the mcmb, which stands for make bucket, and give it the alias URL as well as the name of our bucket, which is MLFlow. We build our container again with docker compose app command. And we can see that there is a MinIO setup container created. Its status is exited, since the container just executes those two MC commands and then exists. Let's check our MinIO interface. We can see that the MLFlow bucket has been created. Great, we are now ready to set up our MLFlow server. Let's define our MLFlow service. Instead of pulling an MLflow Docker image from a registry, we are going to build our own Docker image. The reason we are doing this is because at the time of this video, the official MLflow Docker image doesn't contain all the required packages for MLflow to work with PostgreSQL and MinIO. We'll come to the custom MLflow image just in a moment. For port mapping, because MLflow server uses port 5000, it's natural to expose this port to our host machine. However, if you are using macOS like I am, this will create a problem. It seems that a system service of macOS is also using port 5000, so if we use this port, Docker will complain that the port is not accessible when we try to build and start our container. To fix this problem, we can set the port on our host machine to something like 5001. I believe this problem only happens if you are using macOS Monterey or higher. If you are using Linux, I don't think you will have this problem, and you can just set the host port to 5000. There are 4 environment variables we want to set: the access key, ID, and secret access key, so that MLflow can use MinIO to store artifacts. MLflow S3 endpoint URL is the URL of the MinIO server. MLflow S3 ignore TLS is set to true, so we can ignore the TLS verification to MinIO server. And these credentials are also read from our .env file as well. Next, we define the command to run the MLflow server. And this is, I would say, the most important setting in our MLflow service definition. We run MLflow server with the backend store URL set to our PostgreSQL servers, and we tell MLflow server to use the MLflow database created earlier to store, experiment, and run metadata. The host option specifies the network address on which the MLflow server will listen. In this case, setting it to 0.0.0.0 means that our server will be accessible on all network interfaces in our local machine. The serve artifacts options mean that our MLflow server would also serve artifacts such as models, plots, beside tracking experiments. The artifacts destination option specifies where the artifacts are stored. S3 MLflow means that the artifacts are stored on a package named MLflow on our MinIO server. Now let's create our custom MLflow Docker image by adding a Docker file inside the MLflow directory. I'm using the base Python 3.11 image. We copy the requirements.txt file from our host to the temp directory inside our container. Then run pip install command to install all the packages. Our requirements.txt file is quite simple. Apparently, we need to install the MLflow package. We need the stylecodepg2 binary package so MLflow can work with PostgreSQL. And we also need the Boto3 package so MLflow can work with MinIO. Alright, let's save all these files. And let's build and start our MLflow container. Once the build is completed, you can see our MLflow container is running. And if you check the MLflow database, it has been populated with different tables. Let's go to localhost 5001 in our browser. And you can also see the MLflow UI. Let's test our MLflow setup by running an actual ML experiment. I'm creating a test directory here and add a test mlflow.py file. We are going to run a really simple experiment. First, I import the logistic regression class from scikit-learn library, and then import the MLflow library. Then I call MLflow set tracking URL to set the tracking URL to localhost 5001. In the main code, I'm calling mlflow.startRun to start a run of an experiment. Then define a synthetic input array X and its corresponding label array Y. Then create a logistic regression model and fit it with the input and label. Then I used MLFlow.log metric to log the score or the accuracy of the model to MLFlow. And use MLFlow.sklearn.log model to register my logistic regression model with the signature automatically inferred by MLFlow. Let's run our test script. If we go back to MLFlow UI and refresh it, you can see there's a run created. The short of the run is our test MLFlow.py script. You can also see that the score metric is logged, and so is our model with the signature is scikit-learn model. In the model detail page, you can see the input and output of the model and how to make prediction in different frameworks such as PySpark or Pandas. If we go to MinIO, we can see that there are folders created for our run, and inside the artifacts folder, we can find our models folders with all the files same as what are shown in our MLFlow UI. So in this video, I've shown you how to set up a production-ready machine learning tracking system with MLFlow, MinIO, PostgreSQL, and Docker in your local machine. I'm also including the link to the GitHub repository of all the codes in this video in the description down below, so go check it out. If you find this video useful, please subscribe to my channel and click on the notification bell to get updated whenever I publish a new video. Thank you.